people, I'm Bharat Acharya. Welcome to our new lecture. So yes, today we are continuing with our MCQs on C programming. Last video we had made MCQs on the basics of C programming like variable declarations, if else, etc. Thank you so much for your wonderful comments. Yes, the course on DSA is being prepared, will be released very soon. I tell students all the time, in your first semester when you have C as a subject, learn it very nicely. Not only will you get good marks now, it will set the tone for all the further semesters of engineering. You don't know what's going to come, but ask your seniors. All further subjects involve C programming. Right in the next semester, you have this beautiful subject of DSA, which is the core subject all throughout placements. Your placement interview will be based on your knowledge of DSA, for which you need to know C very well. When we make a course of DSA, we or anybody makes, and anybody teaches you algorithm. DSA means data structures and algorithms. When someone's teaching you that person, that teacher assumes that when he or she gives you the algorithm, you will be able to code it. Us waqt, at that time, if your coding skills itself is a challenge, then you're fighting two battles. A, understanding those complex algorithms. B, okay, I've understood the algorithm, I can explain it to people, but I don't know how to code it. What's the point? So don't get yourself into such a big hole that you cannot come out of. Right now, this is your semester of C, master C, and you will thank me in all further semesters of engineering. You'll be surprised how much this knowledge of C will help you in your remaining course of engineering. Anyway, now let's begin. First question. As always, some questions will be based on your college level. Some questions will be based on GATE exam. Now, when I say GATE, I don't mean only GATE. It means GATE, ISRO, BRC, placement, basically the higher category questions. Because that's what the whole fun is. If I just keep doing easy questions with you, then we're just wasting each other's time. Now, let's begin. Our first question. First one, of course, is very simple. It's a warm-up question, and I'm sure you'll be able to handle it and answer it like this. Some of you all would have already got the answer. Int a is equal to 1, b is equal to 2, x is equal to 0. So three variables are created, a and b have been given values, x is 0. Is also has been given a value, is being given a value 0. What will be x at the end of the program? You can see x plus plus means x is being incremented. You can see there is a loop, so it's incremented various times. So basically the answer is the number of times you do the loop is the value of x at the end of the program. So the same question can be asked as how many times will this loop execute? The answer will be the same. Now, look at the loop. For I is equal to 0. You all know for loop, so I'm not going to explain it. For I is equal to 0 means the starting condition is I is 0. I less than or equal to 10. There is a big difference between writing I less than 10 and I less than equal to 10. When you write less than equal to 10, that means when I is 10, even that time the iteration will take place. This is the catch of the question. Normally, what do we write over here? I plus plus. I plus plus means every iteration I gets incremented. You can also write I minus minus, which means every iteration I gets decremented. You can also write I is equal to I plus something, which means I may change not just by one, by multiple steps. That is up to you as per the program demands. So here I have written I is equal to I plus 2. That means in every iteration I will be incremented by 2. Now, do your logic and tell me the answer quickly. What will be the final value of x? In other words, how many times will this loop be executed? Come on. The options are 10, 20, 5, 6. Pause the video, think, get the answer, continue. Commit to an answer, okay? Don't think two things in your mind. Commit to an answer. You may either be right or wrong, but you need to know whether you're right or wrong. You need to know how good you are, and if you're not good, you need to know that today so that you can improve. Come on, let's see. First iteration. First iteration, I was 0. The iteration will take place. That means x will get incremented. This is the first one. X will get incremented. Your one iteration is over. I will become I plus 2. That means I has become 2. Next iteration, I has become 4. Next iteration, I has become 6. I has become 8. I has become 10. Next item, even then the iteration will take place because it said less than equal to 10. I has become 12. That's when the loop will break. That means this loop will do 6 iterations, which means the final value is 6. If you thought the final value is something like 5, you fall into the trap where most people fall. Yes, if this was less than, just less than, not less than equal to, then 5 would have been the correct answer. But it is less than equal to, which means when I is 10, even then the loop will execute. So you have to count that 6th iteration. And if this was I plus plus, not I plus 2, I plus plus, just normal I plus plus, then you would get how many iterations? 10, 9 or 11. I've changed the question. Come on, how many iterations would you then get? 11 iterations, because 0 all the way up to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which means you would get 11 iterations. All right. So let me just sum it up for you. In this case, your answer is 6. This is the correct answer. And in general, there are various ways in which you do a for loop. If you do 0 and I, starting from 0 and I less than 10, that is the most normal way. That's how I do for loops. That's how I've taught for loops. So you start with 0 and you write less than whatever is your count value. If you do that, 0 and up to less than 10, you will get exactly 10 iterations. If you start from 0 and write less than equal to 10, you will get 11 iterations. If you start from 1 and write less than equal to 10, you will again get 10 iterations. So there are so many ways of writing a for loop. There is no correct or wrong method. It's everyone's own way of doing it. No teacher is going to write the program in 4 different ways and show you. No textbook. By the way, I write textbooks also. My textbook has just got released from Mumbai University. Next week, the Pune University book will also be released. Then I'll make a video about showing both the books and showing you what is there inside the book. Then you can buy whichever one you want to. It will be available on Amazon, Flipkart, everywhere. So it will be available all over India. Anyway, the point here that I'm trying to make is no teacher and no book will write the same program in 4 different ways, though it can be done in 4 different ways. No one's going to write so many methods. The job of a teacher is to teach you how to write one for loop and make you understand this is how it's done with its possible combinations. Then who teaches you what happens when you write from 0 to 10 or 0 less than equal to 10, etc.? It's your own experience. The more programming you do, the better you get at it. 10 books cannot teach you what a few hours of program, a lot of hours of programming can teach you. So programming is learned the best by doing it. So that's what I encourage students in my whole course of C programming. Yeah, I'm sure you've seen it. This is what I keep doing. I teach one program, but when I'm teaching it, I teach all the possible combinations around it. And then with the interesting outputs that we make and the case studies that we take, which is all real world, every program that we do, every topic that we've learned is with real world example, not just boring college examples of Fibonacci series. Of course, we made those also, but the ones that we use in real world, like simple interest calculation, compound interest calculation, petrol pump, that meter when you start, what happens, EMI calculations, fixed deposit calculations, so on, salary slips, things which are used in the real world with all its relevant calculations. When you do that, the best part is you get your result, you change one parameter like simple interest. So suppose you're doing an FD calculation, simple interest, you change one parameter, you see the output, you come to know what's the difference. Not only do you relate it to your real world, but it also enhances your understanding of your own program and makes you engaged more. Once you're engaged, once you like the platform, once you start doing programming, there is nothing stopping you. That is how programmers are created. That's how these wonderful batch of students come out who write programs by themselves. So anyway, coming back, the correct answer over here is C. I took this 6, that is option D. I took this opportunity to just make you understand all the various types of for loops. Now that this is done, can we move to the next question, please? Now, this I've seen it in competitive exams. This is the way the question comes. I'm going to simplify it for you in case you don't understand it directly. What are the iterations for the outer loop and the inner loop? Look here, there are 2 loops inside. IJ, there is one for loop. This is where the loop opens. This is the second for loop. This is where the second loop opens the inner loop. This is the ending of the inner loop and this is the ending of the outer loop. Now, what are the number of iterations for inner loop as well as outer loop? In case you could figure out the loops directly from this image, that is great. In case you're finding it a little confusing, no problem. The way we write it, I like to take that bracket down. So just the way it looks better and easy to understand. And let me just point it out for you now. This is what we are talking about. This is your outer loop. This is your inner loop. This is a nested loop. You know how the nested loop works, right? You enter the outer loop. If this inner loop was not there, you would do iterations of the outer loop and come out. But now, because inside there's one more loop, this is how your program will work. You'll enter the outer loop, you'll enter the inner loop, do all iterations, come out. Again, go back to the outer loop, enter the inner loop, do all iterations, come out. So if there are 10 iterations in the outer loop, there will be 10 into 10 iterations of the inner loop. Tell me, did you understand this or not? 10 is just an example. It could be 5 and 5, 4 and 4. Basically, the outer loop, each iteration of the outer loop will cause the whole loop of the inner loop. Now, pay attention. In both cases, your count is starting from 0 and it is less than 10, which I just explained to you 5 minutes back. This means both loops will do exactly 10 iterations individually. The outer loop will do 10 iterations by itself. The inner loop as an independent loop will do 10 iterations by itself. Because the inner loop is inside this outer loop, for every iteration of the outer loop, there will be 10 iterations of the inner loop, which means inner loop will have 10 into 10, 100 iterations, and outer loop will have 10 iterations. So total iterations of outer plus inner loop will be 10 and 10. No, that's a mistake many people make because seeing both the counts are 10. 9 and 10, certainly not. That 9, that question of 9 comes if people are not sure as to what will happen. This will give you 10 or 9. I just explained in the previous example. If you start from 0 and you keep the condition as less than, not less than, equal to, less than, whatever the number is here is the number of your iterations. So yes, both will do independently 10 iterations, but because this is inside the outer loop, the outer loop will do 10 iterations, the inner loop will do 100 iterations altogether. So your correct answer is 10 and 100. Are you clear? Let me just clean this. Yes, there you go. 10 and 100. What was the last option? 10 and 11. Again, that 11, the question of 11 comes for people who don't understand how loops work. If your concept of looping is clear, you know the moment you see the question, the answer is 10 and 100. Now, these were two college level questions, college VIVA level questions. Now, I'm going to raise the bar. All right? Pay attention. Let's go one step ahead. All right. So the next question is a very interesting question. Now, this is not the question. The question is going to come immediately after this. This is a warm-up so that you're thinking in the right frame of mind before I start the question. So here, take this as a simple, if this is a question asked to you, you should be jumping with joy. The answer should come like this. X is 0, I starts from 0, I less than 10, I plus plus. What are the number of iterations? Now, if you paid attention in the video so far, you know this. If you start from 0 and your condition is a simple less than, not less than equal to, just a less than, then whatever is the number written over here is the number of iterations your loop will perform. Since the count is 10, you will get exactly 10 iterations. So if this was the question, 10 was your answer. But this is not the question. This is a prelude to the question. The actual question is here. Super interesting. Many of my videos are also watched by teachers, which is absolutely fine. As a teacher, I have myself learned, of course, not from videos. When I learned, there were no videos, 90s. But we learned from textbooks written by, in most cases, professors from different universities. So we teachers also pass our knowledge to each other, which is absolutely okay. So if you're a teacher, this is a superb question to ask in your VIVA. If students answer it, pat yourself in the back because you taught them properly. If they don't, it's your responsibility. Next batch, teach this point very well. For I is equal to 0, I less than 10, the third part is not written. What do you write over here? I plus plus or I minus minus or any incrementing condition. That means what is not happening? I is not changing at all. How many iterations will I get? Students say I've written x plus plus, so x is changing, that does the job. No, x changing does nothing to the loop. The loop is based on I, not on x. This was written to confuse you. Don't fall for it. X has nothing to do with how many iterations are performed. So the question is, will you get 9 iterations? I don't know how 9 became an option. This is an exam question, okay? Competitive exam question. Will you still get 10 iterations? Will somehow magically the processor automatically increment I? No, there is no magic. At least not here. Is this an error? By not writing I plus plus, is this an error? Now, this is the most likely answer that students give. No, that's a wrong answer. This is not an error. This is an absolutely perfect syntax. You may not write the incrementing condition here at all. You can put the condition inside the loop, which I have not put, which means I is 0, I is less than 10, next iteration I is still 0 less than 10, still 0 next less than 10, up to infinity. You will get infinite iterations over here because you forgot to increment I. Had you written I plus plus as always we do over here, had you written that inside the loop, then you would have got perfectly 10 iterations. Students who've learned microprocessors from me, microcontrollers from me, you would understand what happened over here is what we do in DJ and Z as an instruction in 8051 microcontroller, or what we do in loop as an instruction in 88E6 microprocessor. Anyway, so what happens is, if you write I plus plus over here, by default I is incremented. If you don't write, that is fine. You can write the condition inside. But if you don't even write it inside, that means I never changes. That means you'll get infinite iterations. So this was the first of the tricky questions from today's lecture. Now, I hope those who got it right, that's great. Those who didn't, no problem. As long as you learned something from here, that's all you need. Now, we go to the next one. Straight from a gate paper. Pay attention. Serious. IJX. You have to get me the value of X after the program. I0, I less than 3, I plus plus. By now you know instantly that this outer loop will do 3 iterations. Are you clear? By now this should strike you instantly. This is the fourth question on for loops that we are doing. For J, if J was also 0, J less than 3, J plus plus, even the inner loop would do 3 iterations, outer loop 3 iterations. So that means inner loop would do 3 into 3, 9 iterations, correct? But there is a twist. J starts from I. That means in the first iteration of the outer loop, J will be 0, 0, 1, 2. It will do 3 iterations. Then it will go back. In the second iteration of the outer loop, J will start from 1. So it will just do 1 and 2. Come out, go back. Now I becomes 2. It's a third iteration. I will become 2. It starts from 0, then 1, then 2. You understand? I is 2. So J starts from 2. That's it. Because when J increments, it will become 3. I have written less than 3. So that means just 1 iteration. So first time the inner loop will do 3 iterations. Next time it will do 2 iterations. Next time it will do just 1 iteration. Tell me, did you understand? Forget, I've still not even spoken about this. Did you first of all understand how the loops worked? This is where I will stop. Now you will answer. There is something written over here as continue. There is some condition. If this condition is satisfied, then this continue will hit. If this continue doesn't hit, X will get incremented. What is the final value of X? Pause. This is a gate question. I want you to answer. Take your time. Yeah, when you are prepared, when you're actually giving the gate exam, you should be able to answer this in 1 minute or probably less. Today you're learning. It's still time for you to reach that day. But since you're learning, take your time. Get the answer. Your goal right now is to get the answer correct. Pause. Let us see. Let's see what have you got. I don't memorize the answer. I'm going to create the answer with you. Let's look at the iterations. I, J, and what is that? X. So I will go 0, J will go from 0, 1, 2. I will be 1, J will go from 1, 2. I will be 2, J will just be 2. Tell me, did you understand this? In the first time when I is 0, J will do, the inner loop will do 3 iterations. Next time when I is 1, inner loop will do 2 iterations. Next time when I is 2, inner loop will do just 1 iteration. So these are the possible times when X could have been incremented. Now, when I plus J, if I plus J is 3, continue will come into picture. What does continue do? Continue skips everything below it for the current iteration and directly goes to the next iteration. Tell me, did you understand? In any loop, if you write continue, the place where you've written continue, the part below it in that loop will not be executed. Program will directly go to the next iteration. Tell me, is that clear? So, if this continue was not written and simply X plus plus was happening, that means X would have got incremented 1, 2, 3, 4, 5, 6 times, and the answer would have been 6. Starting from 0, X increments 6 times, so the answer will be 6. But now, because of this continue condition, let's see when will this increment not happen. I plus j equal to 3. 0 plus 0, 0 plus 1, 0 plus 2. So these three increments will happen. 1 plus 1, 1 plus 2. You understand, right? This is the value of I, this is the value of j. 1 plus 2. This increment will not happen. Tell me, did you understand this? That means the number of times I will get incremented is 1, 2, 3, 4, 5. The correct answer over here is 5. Please tell me, did you understand? The catch in the question was that continuous statement. That continuous statement means if this condition is satisfied, the loop will just continue. It will not do this part. So x plus plus will not take place. So two things that a person needed to know to solve this question. One is, of course, what continue does, which is very simple. It's a theory knowledge. The second is your understanding of loops. Outer loop will do 3 iterations. Inner loop, if it started from 0, would also do 3 iterations. But because it starts from I, when I is 0, it will do 3 iterations. If I is 1, it will just do 2 iterations. If I is 2, it will just do 1 iteration. So if you understood how this nested loop works, the question becomes very simple. I like this question. I go through lots of papers, pick up the best of the questions because I want to train you. So I like this question very much. That's the reason I put it in the video. Now, I hope you understood it. I hope you got the answer. Take a screenshot. Now, let's go ahead. The next one. Another very interesting question. I love this question when I saw it. Almost fell for it myself. Come on, come on. And I am just going to read out the question and not going to give you any hint, because the moment a hint comes out of my mouth, the answer will come out. I is 0, x is 0, I is 0, I less than 4, I plus plus, switch I, case 0, case 1, case 2, case 3. What is the final value of x? Pause the video. Get this answer right. It's again a very recent gate question. Get this answer right. If you get it right, you feel so confident. Especially if you're in first sem right now. You could crack a gate question that too so fast, you got the correct answer. If you made a mistake, nothing to feel bad about. You're still learning. You make mistakes here, that's fine. You don't make mistake when it matters. And that only happens when your preparation is right. Come on, pause the video. What is your answer? Let's see. I is equal to 0, I less than 4. This is the 5th question on this. By now, you should be able to do it in your sleep. Without seeing the question, by just hearing it also, you should understand this loop will do 4 iterations because the count is 4, 0, 2, 4. Are you clear? 0, 1, 2, 3. So your 4 iterations. Switch I, that means it's going to monitor I. In the first iteration, I is 0. So it will do case 0. There is nothing in case 0. So will nothing happen? No. Since there is no break here, case after checking case 0, it will also check case 1. That means x will become x plus I. What is I? 0. What is x? 0. So 0 plus 0. So x is still 0. Are you clear? It reached up to here and then it broke. It did the break. Next iteration. I is 1. So switch I. It will directly come over here. Case 1. X is x plus I. That means x plus 1. So x plus 1. 0 plus 1 is 1. So far x is 1. Are you clear? So far our result is 1. Next iteration. I is 2. Come on. I is 2. So x, it will come directly to case 2. It will not go to case 0. It will not go to case 1. Directly go to case 2. X is equal to x plus 2 into I. I is 2. 2 into 2 is 4. X plus 2 into I. So that means x is 1. 1 plus 4 is 5. That means x so far is 5. Did you understand that? 1 plus 2 into 2. Don't make me break down so much, okay? So that means 5. So far your answer is 5. Next iteration, I is 3. I is 3, case 0, case 1, case 2, case 3. X is not x plus equal to 0. X is directly equal to 0. That means all this was rubbish. X is equal to 0 because in the last case x is 0. So all this was just done to confuse you. If this was plus equal to 0, the answer would have been 5. But it's not plus equal to. This is plus equal to. This is plus equal to. This is just equal to. So this is basically a question for people who know how to observe every detail of the question and not fall for it. So because x, case 3, x is equal to 0, so whatever you did before this is immaterial. In the last iteration, x will become 0 and the loop will break. So the final value of x is 0. Tell me, did you understand this? Right. So these were the questions that I was discussing today. Our course of C programming on our website, bharatacharyaeducation.com, covers a lot. There are 250 MCQ questions. Not just that. There are 40 plus videos where I've taught everything about C. Beginning, installation, running the first Hello World program, mastering outputs. I firmly believe in that. Your own interest in doing programming increases when you see beautiful outputs. Today is the world of UI UX. Apps that look the best are the ones that sell, where your user experience is the smoothest. And that begins, that journey towards mastering UI UX begins from your first programming language, in your case is C. So I've taught how to master printf and get perfectly beautiful looking outputs. Then we worked with variables, done if else, numerous cases, very interesting cases, built calculators, etc. and so on. And then went to loops, then went to functions, went to arrays, gone much beyond, done data structures, that is structures, pointers, linked lists, and so on. Much beyond the scope of many universities' C syllabus, including Mumbai University. But anyway, this is because I like these topics and I found linked lists. If you know C, you should know pointers and linked lists. That's when you peak at your understanding of C. Anyway, so the whole course is there with 250 plus MCQ solved questions, PDFs forms, video lectures, PDFs of all the theory, university papers. I've solved a couple of papers, lots of gate questions like these. There are various videos where I've just discussed gate questions. And there will be more videos coming up. I keep adding videos as and when, like this one. The total fee of the course is $14.99. And the duration of the course is 6 months. You can watch the videos as many times as you want to. Enjoy learning it. Master C. Like I said in the beginning of the lecture, the more comfortable you are with C today, the more comfortable you will be all throughout engineering. One moment, just one thing I want you to know before you go. You will see. Okay? Be truthful. The video is over. Okay, this is just for understanding. If you're interested in building your career, you'll continue with the video. Tell me, colleges have started. You are in the middle of your semester most likely. Look around yourself. Give an honest answer to yourself. How many people in your class? Let's say your class is about 60 students. Okay, I'm just taking a rough average. In that 60 students, how many people really write programs? And give an honest answer. Every assignment, how many people are really doing it? Yeah, 15, 20, correct? If that's the case, I mean, sometimes even lesser, 4 or 5 and the rest of the class copies, or 15, 20 if you're in some really good college. This is not unique to you. I have been teaching since the past 24 years. I've seen this all throughout. This is what happens. This is the most normal case. So roughly about 20 to 25%, 1/4 of the class really writes programs and the rest of the class copies it. This problem doesn't only exist in first semester. So in first semester, when people are so bogged down with other subjects like mechanics and maths and many irrelevant subjects which have nothing to do with your whole field of engineering, but some other day we'll talk about that. So when people are so bogged down with all that and all those assignments, they think, let's not rack our brains over programming. This semester, let's just copy these programs. In the vacation, I will learn, or in next semester, I will cover this up. Let's go ahead with this. Our work is getting done. That's where you get left behind. Take it from me. Okay? Someone who is a part of this. I got a job through college. I've loved programming. It was my most favorite subject. And I have seen people in the class, brilliant potential, excellent in theory subjects, excellent, good marks, don't get good placements. Why? Because at the end of the day, what do people want when placements happen? You check out placement interviews. Just right now, go to YouTube, check out placement interviews. What are they asking? They will ask you data structures. They will ask you programming. The world today lives on programming. Everything around us works because somebody has programmed for it, which will be you in the future. So that same 25% who is right now writing programs will find the next semester easier, will automatically get a lead. Next semester, when you're struggling with the other subjects, you're also struggling with programming. What happens? You think you're going to transform? Yes, some people will. Some people will. 4 or 5 people from the copying lot will move into the programming lot. 4 or 5 people from the programming lot will think, we did so much hard work, others are just copying and getting their job done. Let's just do that. Let's just copy. Next semester, we'll think. That shuffle will happen, but the effective percentage of the people writing programs will be around 25%. and the same will repeat semester after semester after semester and will be directly reflected during placements. Now, if you've been with me so far in the video, tell me, does everybody get placed? Will everybody in your college get placed? Will everybody get good jobs? Will everybody get Google? Will everybody get Microsoft? Will everybody get Intel or Apple or any of these big companies? No. How many percentage, what is the percentage of people in a college that really get good jobs? So in some colleges that even really get placed, or in some colleges where your placement is good, how many people really get the cream of the jobs? This year there was something very strange. Not even IIT could get more than 80% placement. Correct me if I'm wrong. I'm saying what I heard in the news last night. For all you know, it could not be accurate. I'm just passing on information. But I'm telling you what I heard. If IITs couldn't get 100% placement, what is the guarantee that all of you all will get placed? They don't. It's about 25, 30, 40% who get placed. Some colleges 50, 55, some colleges 60%, some 70%. But in that 70%, all 70% don't get the best jobs. The best jobs go only to that cream, where that top 15, 20, 25% of the class. And where does that difference happen? Right from Sem 1. If you are not writing programs in Sem 1, you are creating that trouble for you right now. That separation starts happening right now, which manifests itself into the placement scenario in your 7th and 8th semester. What happens in 7th, 8th semester? It's not like those who have not written programs today will not get placed. Some of them really buckle up, really pull up their socks, disconnect from the whole world, disconnect from social media, disconnect from everything else, put their heads down and learn programming in one semester. What will you learn? Bookish knowledge. What will you not have? The experience of 8 semesters of programming. There's so much that a programming textbook can teach you. There is so much that a good teacher can teach you. And there is so much that you learn by yourself. When you write programs, you play with loops, you play with those ij values, you see the output. That's when your eyes open up. That's when you really learn. And that kind of understanding takes time. This 4 years, make yourself an experienced programmer so that when you sit for the interview, you can answer those tough questions. You can even bluff if you learned it overnight. Get lucky. Maybe the question that you just learned was the one asked to you. Get the job. But if you're not really equipped with the knowledge that is expected of you, just getting the job itself will not suffice. The difference will be shown over there immediately. You may not even be able to hold on to the job, or even if you do, you will not grow the way the others are growing anyway. Not being a pessimist here, I'm just giving you the reality. So, start learning programming now. Wherever you learn it from, start learning now. Not only is the knowledge factor important, it's the experience of making all of those mistakes and correcting yourself and learning those fine things which, like I said, no textbook or teacher can teach you, because there's so much to learn that only your own experience of programming teaches you. So get on with it. Don't waste your time. And there are many more. So not just C, I teach various subjects. The whole list of subjects is written over here. So just to sum up the video, just to tell you what all I do. C programming, COA, again a subject that you'll get most likely in 3rd semester, depending on your branch, but most branches have it. And it's also a gate subject. Microprocessors, microcontrollers, embedded systems, subjects that I love to teach, subjects which are very relevant to everything that we do, including this device, including the camera, including that remote, including the AC, including smart lights, etc., and the board and the whole internet. All of it requires all of these subjects knowledge. So that's what I teach. You'll come across my videos, my lectures in various semesters of engineering. Whichever one you're learning, go ahead, take the course, enjoy learning with real world examples and with a will to learn. Hope to see you there. Wish you all the best. Do well.